Hello viewers, in today's class we are going to solve yet another important and conceptual problem from definite integrals, right? So here we have to solve this integral involving the greatest integer function, right? And here if we look at this integral, we see that we have to integrate this function from e square to e cube, and here the integrand is greatest integer function of log x over e to the power greatest integer of log x, right? So let us call this integral as I, right? So here e represents the famous exponential number or the Euler number, and here the logarithm is the natural log, right? So here the base of the logarithm is e, which is the exponential number. Hence we can say that we are dealing with the natural log ln, right? So now in order to solve this definite integral, we'll make use of the method of integration by substitution, right? So viewers, the method of integration by substitution is a powerful tool to find the values of typical integrals, right? So let us start. Now let us assume u is equal to log of x over e, right? So we'll make this substitution, and we'll take this variable u as log of x over e, right? Now from the definition of logarithm function, we can write this expression as e raised to u is equal to x over e, right? So x is now equal to e times e raised to u, which is x is equal to e raised to u plus 1, right? Okay, so now we have expressed x in terms of u, and now differentiating both sides with respect to u, we have dx over du is equal to e raised to u plus 1, right? So dx is now equal to e raised to u plus 1 du, right? So now we'll use this expression here, right? Okay, so now let us change the limits accordingly. So here x varies from e square to x is equal to e cube, right? So now when x is e square, then we can use this expression to find out the corresponding value of u, right? So u is log e square over e, and this is equal to log of e, which is equal to 1, right? And when x is equal to e cube, then u is equal to log of e cube over e, that is log of e square, and that is 2 log e, and log e is equal to 1, so we have 2 times 1, that is equal to 2, right? So when x varies from e square to e cube, then u varies from 1 to 2, right? So now our integral I can be written as integral from 1 to 2, and we have a greatest integer, and for log of x over e we can write u. So here we have greatest integer u, and to the power here we have a log of x, right? So log of x can be written from this expression, so we can take the log of both sides. So log of x is equal to log of e raised to u plus 1, and using the properties of power rule for logarithms, we have u plus 1 log e, and log e is 1, so we have u plus 1, right? So log x is equal to u plus 1, so here we can replace log x by u plus 1, right? And for dx we can write this expression, that is e raised to u plus 1 du, right? So now our aim is to find out the value of this integral, but here we have to use the definition of greatest integer function. So viewers, here we see that u varies from 1 to 2, right? So when u varies from 1 to 2, then as per the definition of greatest integer function, the value of greatest integer u is equal to 1, right? And now here we have to find the value of greatest integer u plus 1. So what we will do, we'll add 1 throughout this inequality, right? So if we add 1 throughout, then we have 1 plus 1, and here we have u plus 1, here we have 2 plus 1, right? So this is 2, this is u plus 1, and this is 3, right? So when u lies between 1 and 2, then u plus 1 lies between 2 and 3, right? And again, from the definition of greatest integer function, the value of greatest integer u plus 1 is now equal to 2, right? So now our integral I, it reads as integral from 1 to 2, and here for greatest integer u we can write 1, and here we have greatest integer u plus 1. So greatest integer u plus 1 is 2, so we have 1 square, and here we have e raised to u plus 1 and du, right? And 1 square is 1, so we have integral from 1 to 2 e raised to u plus 1 du, right? So now we have to solve this integral. So now viewers, we know that the integral of e raised to x dx is simply e raised to x, that is the function itself. So here we have I is equal to integral from 1 to 2, and we have e raised to u du, and 1e, that is e raised to 1, can be taken outside being a constant, and we have e, and the integral of e raised to u is e raised to u, and the limits are from 1 to 2, right? And now here we can simply substitute the limits and we'll take the difference. So we have e square minus e raised to 1, right? And we can take one more e common, so we have e square, and here we have e minus 1, right? So now we see that the value of this integral I, it comes out to be e square times e minus 1, right? Where e is the famous exponential number, right? So this is how we solve this important definite integral.